All right, heat transfer students, let's talk strategy. In this explainer, we are going to crack the code on your GTU exam 3151909. We're not guessing here. We're using pure data to show you exactly what to study to get the best possible score. Let's dive in. Feeling that pressure? You look at that huge syllabus and you're just wondering, how am I ever going to get through all of this in time? You are definitely not alone. The biggest question is always, where should I put my energy to get the most marks? Well, guess what? We've done the heavy lifting for you. We went back and analyzed every single GTU heat transfer paper from winter 2021 all the way to the most recent winter 2024 exam. So this isn't guesswork or a hunch, it's a real data-driven blueprint for your success. So here's our game plan. First, we're going to look at the overall strategy for cracking the exam code. Then we'll dive in chapter by chapter, starting with conduction and fins, then hitting convection and radiation, and after that, heat exchangers and boiling. And we'll wrap it all up with the ultimate study blueprint that ties everything together. Okay, first up, cracking the exam code. This is all about finding the patterns. So our entire analysis is built on a really solid foundation. We're talking 7 past exam papers. And by digging into these, a super clear pattern emerges. You can literally see which questions and even which types of questions GTU just loves to ask, year after year. Okay, let's get into the specifics. Chapter 1, Conduction and Fins. You gotta think of this chapter as the absolute foundation for everything else you're gonna study. So for Chapter 1, you really need to zero in on what our data calls the exam winners. These are the topics that pop up constantly. That means getting really good at the general heat conduction derivations, tackling problems on composite walls and spheres, nailing both fin theory and the numericals, understanding the critical radius of insulation, and of course, transient conduction. Now, I want you to pay close attention to this number, 4. That's right, 4 consecutive exam cycles have had a question on fins. It can be a numerical problem, it could be a derivation, but it's been there. That's every single year from 2021 straight through to 2024. Seriously, if you only have time to master one thing from this chapter, make it fins. And hey, here's another high-yield topic you don't want to miss, the critical radius of insulation. This is such a classic theory question. Sometimes it's a standalone definition, other times it's tucked inside a bigger numerical problem. Knowing this concept inside and out is just a really smart, easy way to grab some marks. Okay, let's move on to the real core of the syllabus. Chapters 2 and 3, Convection and Radiation. I mean, these two are just packed with the fundamental concepts you have to know. One of the most predictable questions on the entire exam is being able to tell the difference between free and forced convection. Our analysis shows this comparison, or something related to it like defining the Grashof number, shows up in almost every single paper. You absolutely have to know this cold. Free convection is all about density changes, while forced convection is driven by something external, like a fan or a pump. Now for radiation. Look, it's easy to get lost in the details here, but the data points us to a few key must-knows. You want to focus your energy on Kirchhoff's law, the theory and derivations for radiation shields, the concept of a shape factor, and the basics of black and gray body theory. These are the topics that keep coming back. And this chart just makes the pattern crystal clear, doesn't it? Just look at that frequency. The convection types comparison and Kirchhoff's law have shown up for 4 years straight. 4 years! And radiation shields aren't far behind with 3 appearances. These topics are as close to a sure thing as you're ever going to get. All right, let's shift gears and talk about the application side of things with chapters 4 and 5, heat exchangers and boiling. This is really where all that theory gets put to work. Okay, listen closely. If there is one single thing you take away for chapter 4, please let it be LMTD, the log mean temperature difference. I honestly cannot stress this enough. The derivation for parallel and counterflow heat exchangers is one of the single most consistently asked questions in the entire syllabus. The data shows it appears in every single exam cycle we looked at. Now, moving over to chapter 5, we see another classic comparison question that GTU just loves to ask: film versus dropwise condensation. You've got to be able to explain that film condensation creates this insulating layer, right? While dropwise is way more efficient because it lets a fresh surface get exposed. And yeah, you guessed it, this question has also appeared consistently across all the years. So we've walked through the chapters, we've seen the patterns. Now let's pull it all together into your ultimate study blueprint. Think of this as your final checklist for success. We've taken all of that data from all 7 of those exam papers and we've boiled it down into a single, powerful summary. These are the absolute highest priority topics, the ones you just cannot afford to skip. And here is the guaranteed marks checklist. Look at this. These 5 topics have appeared every single year from 2021 to 2024. Every year. From Chapter 1, it's finite numericals and derivations. From Chapter 4, the LMTD derivations. From Chapter 5, boiling and condensation. And from Chapters 2 and 3, that free versus forced convection comparison and Kirchhoff's law. This is your core study plan. Master these 5, and you've built an incredibly powerful foundation for success on your exam. So there you have it, your data-driven blueprint for the GTU Heat Transfer exam. The path is crystal clear. The only question left is which one of these high-yield topics are you going to master first? Good luck!